Hello everyone, welcome back to my channel. So we can see the platforms where you can practice smart contract auditing. Up to the point, we have talked about the smart contract vulnerabilities, how DeFi exploit happen, but understanding vulnerabilities theoretically is the first step. To become a security researcher, you need to be practice auditing real smart contracts. So auditing means reviewing protocols, code base, and trying to identify the vulnerability before attackers find that. The goal of the smart contract audit is the answer like can funds be stolen from this contract? Can user manipulate protocol logic? Are admin privilege secures? Privilege is like admin, you can give the admin to more privilege that is secure to the smart contract. Are there economic exploits in the protocol design? The professional auditors spend hours and even days to analyze the smart contracts line by line and identify the potential risk. Fortunately, the several platforms where the developer can practice auditing real smart contracts and participate in the security competition also. These platforms host a real protocols that went their code reviewed by the security researcher. Let's look the most important ones here. So now we start from here. So here is the CodeHawks. CodeHawks is the competitive smart contract auditing platform that created by the team behind the Cypherin. You know about the Cypherin, they can also do the security auditing. So on this platform, developer practice in the audit contest. A protocol publish its smart contract code base and ask the community to review that. Participants then analyze in the contract and try to discover the vulnerability. The auditing process is usually look the something like this. Like first you download and clone the protocol smart contract repository. You start by the reading document to understand how the protocol works, and then you analyze the architecture of the systems. You try to understand the core components such as the token contract, liquidity pools, wall systems, and the lending mechanism. After that, you begin reviewing the smart contract in detail. You look for the potential issues such as the re-entrancy vulnerabilities, access control mistakes, or oracle manipulation opportunities, incorrect math calculation. Some of the time is many. Some of the time this is happen also, or upgradable smart contract risk. You discover the vulnerability, you submit security finding. A good finding usually includes the vulnerability descriptions, root cause of that issue, and the potential impact, and the proof of concept to demonstrate how exploit could work. So after that after the audit contest finishes, judges review the all submissions. Rewards are distributed based on the severity and the quality of the findings. Critical vulnerability usually receive the highest prize and the highest reward. Platform like a CodeHawks are extremely useful because they stimulate the real workflow and professional smart contract auditors that how that work. So like if you can do the smart contract auditing and the how that work, how you can give that all things you can see here. Like you go for the we go for here and we see the price of that, and there is a contract and the submissions, the getting started, how you getting start this, the non-issue that already known that the scope. So you can see the how the contract is there, and you can view repo and download the repo and see in your VS Code and any other tool. So that is all things are there. So is the live, is the judging, what are the things are happens, reward distributed, then it's already the happen, and that all the rewards are distributed. You can find the all content, the private only, the invite only, all public, and here is you can see the ended one and already started upcoming. What is the upcoming one? That all things you can see. If you don't know about, then you can start it from here. You can see that first flights means like whatever the you want to first. You are the starting to smart contract auditing, then you start with here competitive. What is it's this, we can see that leaderboards also here. So the what kind of person, that how much earning they have, how much the findings, that all things are given here. So this is the one of kind of CodeHawks too. Then the other one we do see there. This is Code for Rena. This is the another well-known auditing platform for the Code for Rena. And Code for Rena is also host a competitive smart contract audits, but it has own operating longer and has a large community of security researcher. The process is similar. The protocol submit the smart contract of the review and security researchers, sometimes called wardens, analyze the code base and try to identify the vulnerabilities. During that audit contest, dozens and sometimes 100 of researchers may review the same protocols. Each participant submit the vulnerability report. The report typically include the vulnerability code locations, explanations of that vulnerability. That is also important when you do the auditing. The attacker scenario and the mitigation recommended. After the context test ends, judges evaluate the findings. Vulnerability are categorized between the severity levels such as critical, high, medium, and low. This is the 4 types and levels. Rewards are then distributed among the researchers who discover the valid vulnerabilities. Some of that you can find it, but that is not valid, so you cannot get a reward. Many professional auditors actually started their careers to participating in the platforms like a Code for Rena. It's one of the best way to build experience and learn how real audit works. Then we go to finding other things, that is a HATS finance. HAT finance is a slightly different from the competitive audit platform. Instead of hosting time limited contest, HATS finance provided decentralized bug bounty programs. So project deployed the bug bounty values that hold rewards for the security researcher. If someone discovered the vulnerability in a protocol, they can submit a report through the platform. The project team that reviews the report and the verifies the vulnerability. If the report is valid, the researcher receive the reward from the bounty vault. The model encourage like responsible disclosure. Instead of exploit vulnerability for the profit, researcher can incentivize to report issue of the product. Bug bounty platforms have helped prevent many major exploits. Sometimes researcher discovered the vulnerabilities that could have caused millions of dollars in losses. So now we can understand the how smart contract auditor actually analyze the contracts. So first is like when security researchers analyze a smart contract, they usually follow the structures process. First, they study the protocol architecture. Then they ask a question like, what is the main purpose of this protocol? How do users interact with it? And where the funds is stored? So next, they review the smart contract code. They see the critical functions such as deposit, withdraw, liquidation, minting, governance sections. They took up potential vulnerabilities such as a re-entrancy risk, incorrect permissions checks, unsafe external calls, and the Oracle dependency, math errors. Security researchers also analyze the edge cases of attack scenarios. For example, of like what happens if someone manipulates the price feed? What happens if user calls function repeatedly? What happens if someone uses a flash loss? By thinking like an attacker, auditor can identify the weakness before that exploits happen. So the by practicing, I talk many times about the practicing. So why the practicing auditing is important. Reading a vulnerability is helpful, but a real skill comes from the practicing in security, analyze on real protocols. Platform like CodeHawks, Code for Rena, Head Finance allows developer to gain experience analyzing complex smart contract systems. So many professional security researchers spend years participating in these platforms and the studying exploits reports. Over time, they develop intuitions of the sporting vulnerability because they are solving the many of the other smart contract before, and the skill has become extremely valuable for the DeFi system. For the DeFi system continues to grow. But auditing smart contract is just not a reading code. Security researchers also rely on specialized tools that help to analyze the contract, detect vulnerabilities, simulate attack scenarios. Like if you read by how many lines of code and after the each of the line you find this and this. Instead of that, they are getting to use the specialized tool. In that next sections, we are exploring the most important tools used in the smart contract auditing, including the static analysis tool, fuzzing frameworks, or testing environment used by the professional auditors. Also, they are use this. So we are also seeing this kind of professional tools. So up to this point, we are talked about the vulnerabilities, real exploit platform where the security researchers audit smart contract. But one of the most effective ways to learn smart contract security through hands-on challenges. Just a reading about vulnerability is not enough. To truly understand how attackers work, you need to break down the contracts by yourself. Security researchers often practice by solving intentionally vulnerable smart contracts challenges. This platform simulate the real vulnerabilities so developer can learn how attackers exploit them. So let's look some of the most important training environment of using Web3 security community. So first is Ethernet. That one is not here, but we can see. So Ethernet is one of the most well-known smart contract security platforms. It was created for the security team of OpenZeppelin. If you know the whole smart contract, you know the OpenZeppelin what is. So the platform works like a blockchain hacking game. Each level, so we can see this Ethernet OpenZeppelin library. So each level contains a vulnerable smart contracts. Your goal is interact the contract and discover how exploit and vulnerability happen. To solve the level, you usually need to analyze the smart contract code, understand how that behaves, the craft transactions that breaks intended logics. Some of the vulnerabilities learns Ethernet include like reentrancy attacks, delicate call misuse, integer outflow, underflow, improper access control, storage manipulations, weak randomness. That all things here already have. For example, in the reentrancy challenges, the contract allow withdrawal before updating balance. You must write the malicious contract. The repeatedly calls withdrawal function to train the funds. This exercise teaching the exact mechanism behind the famous DAO hacks. So the great thing about Ethernet is forces developers to think like attackers. Instead of just reading theory, exploit you can actually exploit the contract, see the vulnerability, and happen in practice. So here you have some of the steps. You can see that all of the steps, how to deploy, building, and all of that. And here the all contracts are there, how to contributing in them. That all details you can, if you see and refer this, you can know the more detail about that. Then the other one is Dame vulnerability DeFi. Here we can see the website also, how that work. Yeah, they have a challenges also here. Vulnerability DeFi is a collection of advanced security challenges focused on specifically on DeFi protocols. Unlike Ethernet, which is focused individual vulnerabilities, this platform teaches the complex DeFi exploit involving the multiple contracts and the financial logic. These contracts stimulate realistic attack scenarios that have occurred in a real DeFi protocols. Some example of flash loan, Oracle manipulation, governance taken over, liquidity pool, token approval vulnerability. In many challenges, you start with almost no funds. Your goal is to exploit the protocol logic and the drain assets from the system. For example, one challenge may involve using the flash loan to manipulate token prices inside to automated market maker AM. So another challenge might have involving gaining temporary governance voting power and the passing malicious proposal. This exercise help developers to understand how economic attacks work in decentralized finance. This is extremely valuable because many modern DeFi exploits are not simple coding bugs. They are the economic attacks involving complex protocol interactions. So the third is capture the ether. So this is a website. Is the Capture the Ether is another popular smart contract security challenge platform. It contains server hacking puzzles that teach Ethereum security concepts. The challenges covers topics such as like smart contract storage manipulations, contract ownership exploit, or cryptographic vulnerabilities, unsafe randomness. These exercises help developers understand low-level behaviors of Ethereum virtual machine. Learning this mechanism is important because the many vulnerabilities occurs due to subtle EVM behaviors. So we can find this in this. So you can search on that and just see what are the things that are available in this. The other one is the Peridium CTF. So this is a website. Uh, this is the GitHub repo of the Peridium CTF. This is an advanced security competitions created by the Peridium research team. And these challenges are significantly harder or often involve complex DeFi systems. Participants must analyze a large code base and find creative exploit paths. These competitions stimulate the type of work professional security researchers perform when auditing real protocols. Many top contract auditors regularly participate in CTF competitions like this, sharpen their skill. The other one is Secureum Bootcamp and the security challenges. If you go to bootcamp, you have like a open to be Discord and whatever they are announcing and details about that you can show in that. So Secureum is a well-known security education initiative focused on Ethereum security. They run a boot camps and workshops that teach developers how to analyze the smart contracts. The challenge often involved identify vulnerabilities inside real exploits. Secureum has helped to train many developers who later became a professional smart contract auditors. So, why these challenges are important to you also? Smart contract security is a skill that develops through the practice. When you solve these challenges, you begin to recognize common vulnerabilities patterns. Over the time, you start to notice things like unsafe external calls, missing access control checks, Oracle dependencies, upgradable proxy risk, and incorrect math calculations. These patterns are exactly what security researchers look when auditing real protocols. Many professional auditors started their journey by solving the security challenges like this, and they learn how vulnerabilities works in a practice before analyzing a real protocol. So the how developer usually approach these challenges, like that when solving the smart contract security challenges, developer usually follow the some secured structure process. First, they read the smart contracts code that try to understand its invented behaviors. Next, they analyze the critical functions that control funds or permissions. They think about the possible attack scenarios. For example, can a function be re-entered? Can a balance be manipulated? Can external contract interfere in the executions? Can the price be manipulated? And finally, they craft transactions or write exploit contracts that trigger the vulnerabilities. This process is similar to the what professional auditor do when reviewing the production protocols. Uh, so the learning smart contract security is not just about the reading documentation. It requires actively breaking vulnerabilities, contracts, and the understanding why exploit works. Platform like Ethernaut, DEM vulnerable DeFi provide a safe environment where the developers can experiment with the vulnerabilities without risking real funds. By solving these challenges, developers build the intuitions needed to analyze real DeFi protocols that identify the security risk. So after these things have all of that, how you can challenges too. Then other part is like this is the professional tools. The tools are used for the smart contract auditing. So understanding vulnerability is important, but professional smart contract auditors don't rely on the manual code review. Don't see the first like line by line code. They also specialized security tools that help to analyze smart contracts automatically. So whatever the tool available in the market, they use first that, and if that tool is also the showing some vulnerability, they solve first that, and then after they solve other vulnerabilities and check other things. So these tools to help auditors detect potential vulnerabilities, simulate attack scenarios, and How contracts behave under unexpected conditions. Smart contract security tools usually fall into the several categories: static analysis tool, the testing framework, fuzzing tools, and the formal verification systems and transaction stimulate tools. Let's go through with the most important tools that used by the professional auditors and security researchers. So the first one is a Foundry. So Foundry has like a GitHub. I will show you that also. So Foundry is one of the most powerful framework of Ethereum smart contracts and developing and the testing. It is widely used by the developer and the auditor because it provides extremely fast testing and advanced security testing capabilities. Auditor use a Foundry for the writing unit test for the smart contract, first testing contract, running invariant test, stimulate mainnet safe using mainnet forking, testing attacking scenario also. So Foundry includes the several command line tools that is we can see here. There is a command line tools of the Forge. Forge is used for the compiling and testing smart contract. Cast is used for interacting with the nodes, Ethereum nodes, and Anvil is the local Ethereum development node. And the Chisel is the Solidity REPL. Solidity REPL for the quick experiment. Chisel. So how the process of the Foundry installing that all the process is given here. So whenever you want to creating a project, then like Forge init my project, my audit project, or like go into project and Forge build. So they compile the contract and Forge test, they run the test, all the tests you that doing in that. So security testing in the Foundry, auditors often write a first test, and that is important in that. Like they write a first is like amount zero, then the deposit amount and the withdraw amount. So the fuzzing automatically runs thousand of random inputs, detects unexpected failures. This helps identify the issue like incorrect arithmetic, state inconsistence, and unexpected edge cases. Foundry is one of the most important tools used in the modern contract audits, modern smart contract audits. Then we showing other is a Slither. Slither also the one of the best for the smart contract audit, and that is static analysis tool that created by the security company of Trial of Beats. This tool is created by them. So the static analysis means analyzing smart contract without executing it. Slither scan the solidity code automatically and detects common vulnerability. And they said like a percentage of vulnerabilities and all this. It can detect issues such as re-entrancy risk, unused return values, uninitialized variables, dangerous delicate goals, incorrect inheritance patterns, and complex code paths. Slither can analyze the entire code base within a second, and they can give you the uh, Excel no box kind of format of how many lines of code and that all the details, what they want, what they think about the percentage of vulnerabilities and all that in the one box details. So the install Slither is pip install Slither is like pip install pip3 install Slither analyzer, and you can run anytime in the Slither space dot, and the Slither will scan the entire contract and the generate vulnerability report. In short, in that thing, they give the report. And example output show what is a possible reentrancy in withdraw, unprotected ownership transfers, missing event emissions. That auditors can often run Slither early during the audit to quickly identify the obvious problem. So that use that and they identify that problems initial and they solve that first. Like they also like given this kind of detectors how kind of what kind of problems they detect. Here's the all information also about here. You have to visit and more detail learn about this. Echidna. So this is a property based fuzzing tool. Echidna is the property based fuzzing tool Ethereum smart contracts. So you can see this way. So instead of manually writing the test cases, Echidna is generated thousands of random transaction test current behaviors, and it is a commonly used for invariant testing. An invariant is a rule that should always remain true in the protocol. For example, total supply should never decrease incorrectly. User balance should not become negative. Deposit fund should always remain recoverable. Ankita is repeatedly generated random inputs and the attempts to break the rules. If the invariance fails, Ankita finds a bug. So like this, if you can see the more in detail, if you use that, then you can know about this more. So you can install by the Docker pool also and run test in that. Then is Aderyn. Aderyn is another static analysis tool by the Cypherin. This is made by the Cypherin. It is designed specifically for the smart contract security analysis and integrates well with the modern Solidity developments. Aderyn detects issues such as re-entrancy patterns, storage layout risk, and unprotected functions, dangerous external calls. Many auditors use Aderyn together with a Slither and deeper analysis. Mostly the auditor not use the one tool, like they can merge whatever they like. Mostly use like a Slither and the less line, how many lines of code, how many vulnerabilities, they can go by their way to be like most vulnerable first or most least vulnerable first, or like more line first or less line first, that kind of things by them. So we can install it like with a git repo also, and here are the all functions of that, how you can install in this. So for the test, you can Aderyn space analyze space dot. So that is, this will produce a detailed vulnerability report. Then the Satora. Satora is the formal verification platform used by the large DeFi protocols. Formal verification is different from the testing. Instead of running random tests, it mathematically proves that certain properties always hold. For example, user cannot withdraw more tokens than the deposit. Did you know that? Total supply always remain consistent and admin privilege cannot be bypassed. So Satora uses a formal logic to verify these guarantees. And major protocols like Aave, Compound, Uniswap have used this verification system like a Satora to verify critical smart contract logic. Formal verification is extremely powerful but also more complex to set up. And the additional tools are like Tenderly. So Tenderly is used to stimulate transactions and the debug contract execution. Auditor use Tenderly to stimulate exploit, analyze failed transactions, debug contract interactions. It provides a visual executions traces showing the exactly how the transactions execute. Then it is a Mithril. So Mithril is a symbolic execution tool for a smart contract. It analyzes the smart contract bytecode for the searchers and for vulnerabilities. It can detect issue like integer overflow, reentrancy vulnerabilities, unchecked external calls, and like that way. You can see the how that work and all the details here. Then is a Manticore. Manticore is currently that public archive repository archive by the, but you can see that, and you can find similar kind of this by another also. Manticore is another symbolic execution framework developed by the trial of bits, the same of by before also. It allows to researcher to explore different executions path in the smart contracts to detect vulnerabilities. So here we are seeing about all professional auditors tools. Do not use all tools together. You can find, like, you can use the tools and you can find whatever the best for you and whatever you know the more that you in default you use more. All the tools you have to in the one go, it's not best, or you can use and you can find what is the good for you and what is the very helpful to you. So different auditors are using the different tools. So the how auditor use these tools together. So professional smart contract auditors rarely rely on the one. I don't tell you like rely on the one tool. Instead of work that combine the techniques, a technical workflow should be like read the protocol documentation. Always be you should have to be read first protocol documentation so we can know the what these protocols have to do and what are the main thing to do, and what kind of vulnerabilities that happen with these protocols. With all the details, we can know better. So review contract architectures and run static analysis using Slither or Aderyn. That is the best for the first time. Write test using Foundry. After that Slither and Aderyn you use, you can get a in the Slither you can get a properly box kind of things that all giving the vulnerabilities and all things. Then after according to that vulnerabilities they're showing, you can do the first test, write a first test and using the Echidna also, and stimulate attack scenario with a tenderly, and apply for formal verification using the Setora for a critical logic. And you can do whatever you like if you like to buy on self or another tools, you can do. So tools that help to automate vulnerabilities detections, but human analysis is still essential. After this, all the tools, that is not okay to be um, you are doing the smart contract vulnerability or you become a smart contract auditor. No, after use this tool, then also we have to see the code, and so that the human analysis is essential. Many vulnerabilities involve complex economic logic, but automated tools that cannot easily detect. So the key idea is smart contract auditing is a combination of manual code review, automated analysis tools, and security testing frameworks, economic attacker analysis. So these all things you use, and the developer who want to become a smart contract auditor need to become a comfortable using these tools, also learning how to think like an attacker. This all things we can see about the audit workflow, how that you can workflow you can decide. If you want to become a smart contract auditor, the most important thing to understand is that auditing is not just about reading Solidity code. It's about understanding how decentralized systems behave under adversarial condition. A good auditor looks at a protocol and immediately starts asking question. What assumption does this protocol rely on? What happens if this assumption break? What could economic incentive be abused? This kind of thinking takes time to develop. It's not like one to contract you can do the audit, and this things this asking the question personality you can develop. You need to strong technical foundation in a Solidity, in Ethereum, in virtual machine. You need to understand how DeFi protocols work internally, and you need to develop a security mindset where you consistently analyze how a systems might fail. Another important skill, the ability to navigate complex code base. Modern DeFi protocols can contain a dozen of contracts interacting with each other. Understanding the architecture, this system is often more important to analyze individual lines of code. But one more thing to really accelerates learning is a studying real exploit. After that you can get more and more knowledge about the code and how that happen, all the details. When you analyze how past attack happens, you start recognizing that pattern in the code, whatever you the auditing. So you begin the same categories of mistake appealing again and again in the different protocol. So if you can see, then you can remove that. And over the time, you develop an intuition to identify this weakness before they become a real exploit. Most professional auditors build the intuitions by continuously reviewing the code, participating in audit competitions, and solving security challenges. It's a process to take persistence, curiosity, and the willingness consistently learn. Because the security landscape in Web3 involves extremely fast, new DeFi primitives appears, new attack techniques appears and emerge, and the complexity of these systems continues to increase. So become a strong auditor is less about memorizing vulnerability and more about developing a deep understanding about how decentralized system works. So how that pattern and cheat sheet is here, like check the effect and all of that. So the people look the blockchain today, they often to see the hacks, the exploit, the billions of dollars lost across DeFi. But what they are really seeing in something else, they are witnessing the early stage of new financial infrastructures being built in the public. So every smart contracts deployed today becomes a part of global permissionless financial system, a system where anyone in the world can interact with the financial protocol without intermediators. So, but with that openness comes from the difficult challenges. This system must operate in a fully adversarial environment. Every line of code can be analyzed. Every line of every assumptions will be tested. Every vulnerabilities will eventually discovered. This is why security researchers, smart contract auditors play such an important role in this ecosystem. There are not just finding bugs; they are strengthening the foundations of decentralized finance, because the future of the blockchain is not just about the faster transactions of a new token. It's about building a system that people can trust with their money, their assets, or their eventually entire financial lives. And that trust begins with a secure code. So whether you are a developer, security researchers, or someone exploring this field for the first time, remember this: the system we are built today may become an infrastructure tomorrow, the global economy, tomorrow's global economy. And the people who understand the security will be the ones who help them make future possible. Here our things are end. Here's a sum of whole of infamy. It's like some of the attacks that happens, how much amount, and learning roadmap of how you can do the better. The auditor tools like single POC is like this work, that kind of work, and beginner, that intermediate, advanced, how that they are used. Hands-on security challenges, how you can, for the beginner this use, intermediate you can use this, advanced, the common mistake of beginners, how you can not do that. And this is the our closing. So here's the our security guide of Web3 security guide is over. How you can do a become a auditor or smart contract security engineer. So you know that what are the process. So here our all topic is over. So goodbye everyone.